So in this lecture, we will create a queue using Python list without setting size limit, which means that we are not setting size capacity for this queue over here. So the first thing that we are going to do, we will create queue class. Then inside init function, we will create an empty list. So here we are initializing an empty list. So I'll call this list items. So here I've initialized an empty list. When we are creating an object of this queue class, this empty queue is created. So the next method that we are going to edit over here is str method. So you know that this method is called when we are printing this queue over here. So I'll modify it to print it out our queue properly. So I will modify str function like this. So this is standard function of Python. When we call print statement on this queue, this method will be called. So here I will create another list in which we need to convert the list elements to the string. So here, then between these items, I will put one space. So return, here I'll put one space, to join these values. So with this, we can print out our queue the way that we created in the previous slides. So let's see what is the time and space complexity for the creation of queue. So in this case, the time complexity is O1 because here we are just initializing empty list. And the space complexity is also O1 because in this case we are not inserting any elements to this list. So the space complexity is also O1. Now the next method that we are going to create for this queue is empty method. So the reason that we are going to create this method first is we will use this empty method inside other methods. So that's why I'm creating it first over here. So I'll declare it like this is empty. So by default it takes self parameter. So how can we check that if this queue is empty or not? So to check it, if the items list is empty, it means that we don't have any element in this queue. So it means that this queue is empty, so we can return true. So if self.items equals to empty list, it means that this queue is empty. So I will return true. Otherwise, we will return false. So this is empty method for the queue that we are creating over here. So it's obvious that the time complexity for this method is O1 because here we are just checking if the list is empty or not and returning true. Otherwise, we are returning false. We know that from time complexities lecture that if condition takes O1 time complexity. So here it takes O1 time complexity. Now it's obvious that the space complexity is also O1 because in this case an extra memory is not required to perform this method over here. Now the next method is enqueue method. So after this I will create enqueue method over here. One more time over here we will use Python list standard method which is append method. We know that append method inserts elements at the end of list. So in this case, we know that when we are inserting an element to the queue, we are inserting at the end of the queue. So append method is useful for this case. So I will declare our enqueue method like this. We know that in the world of queue, we are not using insert, we are using enqueue. So that's why I will create an enqueue method like this. It will take self parameter and value. Then I will call append method of these items over here. So we know that append method adds an element at the end of list over here. So after calling this, I will return saying that the element is inserted at the end of queue. So with this, our enqueue method is finished. So let's see what's the time and space complexity for this method over here. So we know from the standard functionality of the Python that when we use append method, it's insert an element at the end of list. And when we reach list's default capacity in the memory, we need memory reallocation. So the time complexity for this method over here is amortized constant, which means that when we have many elements in the list, so reallocation might be very time consuming. It might reach ON, even ON squared time complexity. So this method will take, in the worst case, ON squared time complexity. Now the space complexity is O1 because here in each case, we are adding only one element to the list. So the space complexity will take for this method is O1. Now, before continuing to the next method, I just want to check that if these methods over here working properly or not. So the first thing that we are going to do, we will create custom queue by using this queue class. So when we initializing the object of this queue class, we know that we are creating queue. So then I will print out the value of isEmpty method. So custom queue.isEmpty. So let's run our code to see that if this is working properly. Then I will check enqueue method. So in this case, if we run it, so you see that we have problem over here. So I missed to put X over here. So if we save and run it, you see that in this case it returns true, which means that our queue now is empty. Now if we call our enqueue method and insert some values to it, then print out the queue, we will see that if this is working correct or not. So in this case, I will print out the queue. I'll call the enqueue method. So here I'll put, for example, 1. So this is the first element that we are inserting, which means that it will be in the first, so then second, then third. So after calling enqueue method several times, let's print out the custom queue. So let's save and run our code. So you see that we have successfully inserted elements to the queue. So every time when we insert new element, it's located at the end of queue. So this is first element, this is second, this is third. So everything is working fine for now. Now let's continue to the next method. The next method is the queue method. So we know that in the world of queue, we are not using remove keyword, we are using dequeue keyword. So here I will create the queue. So it will take self as a default parameter. So let me just put like this. So we know that when we dequeue the element from the queue, we have to remove the first element from the list. So in this case, the first condition over here is we will check if this queue is empty or not. So if self.isEmpty, it means that we don't have any element to the queue. So we will return saying that there is not any element in the queue. Otherwise, we will remove the first element and return it. So we know that once again we have standard functionality of Python list in which we can remove first element and return it. So to do so, we will use pop method over here. We know that if we call pop method without any parameter, it removes the last element from the list. If we call it with the parameter of 0, it will remove the first element from the list. So in this case, we will call pop with 0 parameter. So 0 is the index of first element in the list. So in this case, it will return the first element and first element will be removed from the list. So let's save our code and run it to see that if this is working properly. So after enqueuing some elements, we have printed out queue over here. Then instead of printing out this one, I will call the queue method over here. Then after calling the queue method, I will print out the queue to see that if the element is removed or not. So let's save it and let's run our code. You see that when we call the dequeue method, the first element is returned. So our first element is 1. Then when we print out the queue, we see that the first element is missing. So we have 2 and 3 over here. So our dequeue method works perfect. Now let's see what is the time and space complexity for this method over here. So if we start from the beginning, we saw that checking if condition, if the queue is empty or not, is taking O1 time complexity. Now this part over here takes ON time complexity. So you might be interested why? Because we know from the standard functionality of Python list that if we remove an element from the beginning of list, all elements from the right have to shift one step left. And this operation is very time consuming, so it will take ON time complexity. So for this method, it takes ON time complexity. Now if we combine all these complexities, so we'll get that the queue method takes ON time complexity. Now the space complexity is obvious that is O1 because here we are just removing one element from the list. Now let's continue to the next method. So the next method is pick method. So we know that pick method returns the first element from the queue. So here I will declare it like this, pick, it takes self parameter. Here again, we will check if the list is empty. We are returning saying that there is not an element in the queue. So that's why I will copy this part from here and put it here. And in else condition, we are returning the first element. So here I will put items. We know that 0 is the index of the first element. So by doing so, we are returning first element from the list. Now let's see what is the time and space complexity for this method also. For this method, the time complexity is O1 because we know that accessing any given element of the list is O1 time complexity. So here we are just returning the first element. That's why it takes O1 time complexity. Now the space complexity is also O1 because here an additional memory is not required to perform this method over here. Now finally, the last method is delete method. So we know that delete method in case of queue is responsible to delete all elements of the queue from the queue. So here we will declare delete method like this. So in this case we will just set items to none. So in this case all elements will be deleted from the memory when we call this method over here. It's obvious that the space complexity for this method is O1 because here we are just deleting all elements from the memory, and the time complexity is also O1 because here we are just setting the items to none, and this operation takes O1 time complexity. Now let's check these two methods in our case. So here I have inserted elements, so instead of calling dequeue I will call pick method. So in this case it should return 1. Then I will call delete method. So here if we run our code, you see that the pick method is returning the 1. So then we are deleting all elements from the custom queue over here. With this method, we have completed this lecture. So in this lecture, we have implemented queue methods for the queue in case of Python list in which we don't have size limit. Okay, now we have learned how to create a queue without capacity using Python list, and we have implemented all queue operations. Now let's combine all methods together to see the big picture of time and space complexity for this queue over here. So here we have put all methods together. So let's get started from the first method. The first method is creation of queue. So in this case we are creating a queue without setting capacity, and we are creating an empty list. So in this case the time complexity for creating an empty list is O1, and it's obvious that the space complexity is O1 also because here we are just creating an empty list. Now the next method is enqueue method. So in case of enqueue method, we know that whenever we enqueue an element to the queue, we are placing this element at the end of queue. This means that, so here we are using standard method of Python list, which is append method. So to add an element at the end of list takes O(n) time complexity. In the worst case, it might take O(n) squared time complexity as well. That's why the time complexity for this method takes O(n). Now the space complexity is O1 because in this case we are adding only one element to the list. So this will take O1 time complexity. Now the next method is dequeue method. So we know that in the world of queue, we are using dequeue method instead of remove method. So in this case, we are returning first element and removing the first element from the list. So we know that removing first element from the list causes to shift all elements one step to left. So this is very time consuming operation, and this operation takes O(n) time complex. That's why the dequeue method in this case using Python list without capacity takes O(n) time complexity. Now the space complexity obviously is O1 because here we are just removing one element from the list. Now the next method is pick method. So we know that pick method returns only the first element from the queue. So in this case, to access any given element in the Python list takes O1 time complexity. That's why returning first element using the index of 0 takes O1 time complexity. Now the space complexity obviously is O1 because here an additional memory is not required to perform this operation. Now the next method is empty method. We know that when we are using isEmpty method, we are checking that if the list inside queue is an empty or not. So in this case we are only using if condition, and we know that if condition takes O1 time complexity. Now the space complexity is also O1 because here again any extra memory is not required. Now finally the last method is delete entire queue. So we know that when we delete entire queue, we are just setting this queue to none. So all elements of the queue will be deleted from the memory. So we know that deleting a queue from the memory in this case takes O1 time complexity. That's why the time complexity is O1, and the space complexity is also O1 because here we are just deleting all elements from the space. So an additional space is not required to perform this operation. Now with this, we have completed this lecture. So in this lecture, we have learned how to implement a queue using Python list without size limit, and we have performed queue operations on this queue over here. Now in the next lecture, let's create a queue using Python list with capacity limit. In this case, the queue is very efficient in terms of time complexity. So see you in the next lecture.